So Bones seems to be very interested in our stars, okay? And so that's what we decided to talk about today. We're going to talk about stars and see how these stars go through their lifespan, or we call them their evolutionary track, okay? And what we do in order to track stars and see where they are kind of in their lifespan, as you say, even though they're not alive, is we use something called an HR diagram. Um, and this is an example of an HR diagram. Here's one example. There's lots of different looks to them. They're made differently. So that's one that I like to use. Here's another one. Okay, this is a more common one that you'll see. All right. And then we have a more simple one down here. Okay, so these are what's known as HR diagrams. And again, what HR diagrams do is they show you where a star is in its evolutionary sequence, okay? Stars that you look up and see in the sky, remember, they're just suns. They have their own solar systems, but they change size, they change temperature, and they change luminosity, which means how bright they are, okay? And as these changes happen, okay, stars kind of grow up, and then when they die, they kind of form a black hole that they collapse into. So this is kind of how we see where a star is in its evolutionary track, like I said. Now, the main part of an HR diagram is called the main sequence of stars. That's this middle stripe here, this middle line, okay, of stars. That's where a star spends most of its time, okay? And here's our sun right in the middle here, all right? Now, how do you read this? Okay, it's kind of tricky. Down on the bottom, we have the temperature in degrees Kelvin, all right? Now, on a normal graph, usually what you do is you would start with lower temperatures being in here, and you would go, at the farther right you would go, okay, they would get to warmer temperatures. On the HR diagram, it's reverse, okay? Here are the warmer temperatures, here are the cooler temperatures. So out here it says 3,000 degrees Kelvin, and the stars actually get hotter as we move closer to the left side of the graph. Now, as we're going up the graph, this is the luminosity. This is how bright they are. This is done pretty normally, okay? They are not as bright down here. They are dim stars, the lower you are on the graph, and they get brighter as you go up, all right? So that means the stars that we locate in this top left-hand corner, these are your hot and very bright stars, okay? Down here in the bottom corner, these are your very cool, dull stars, okay? If we go up into the top right-hand corner, we've got very bright stars, but they're not very hot. And then if we come down here into this corner, we've got very hot stars, but they're not very bright, okay? Now, we can classify them into different classifications, okay? We've got our white dwarfs here, all right? We've got our supergiants up here, regular giants, and here's our main sequence again. We're just an average star in the middle of its evolutionary stellar track. Not too hot, not too cold, not too bright, not too dull. We're kind of right in the middle of our main sequence. All right, so that's, you just have to be able to read it. And if I ask you where a supergiant is, if it's, is it very bright or if it's dull, you tell me if it's hot or if it's cold. You just have to be able to read the chart. And there's lots of different kinds of charts that you can reference to out there. Okay, so here's another one. Again, here's our white dwarfs. Okay, and you can see our white dwarfs are hotter than our sun because they're closer to the middle of the graph, the left-hand side of the graph. That means they're warmer than our sun. All right, because they are lower on the graph, all right, they are also duller than our sun. All right. If we go up here to the giants or the supergiants even, okay, you can see they are much brighter than our sun, but because they're on the right side over here, they're cooler than our sun, okay? So that's how you read an HR diagram. Again, most of our, most stars' lifespan, okay, stays right in here in the main sequence, and as they start to change size, change brightness, and change temperatures, they can become different types of stars like blue giants, red supergiants, red giants, white dwarfs. But again, most stars kind of hang out in this area for most of their lifespan. And that's how you read an HR diagram.